Lesson 5-6, the quadratic formula. The quadratic formula gives us another way to solve a quadratic equation. We've learned how to solve them by graphing, by factoring, by completing the square, and here's just one more method that will work for any single quadratic equation. So here it is. If you have an equation in standard form, ax squared plus bx plus c equal to 0, the solutions x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This really gives us two solutions here because of the plus and minus sign. The positive sign in the middle will give you one solution, and the minus sign will give you another. Here's an example. We're going to solve 2x squared plus 4x equals 5. Now the first thing I notice is that it's not set equal to 0, so I'm going to subtract 5 on each side and rewrite this in standard form. So my equation becomes 2x squared plus 4x minus 5 equals 0. Now if you want to, you can now label a, b, and c because you need to use a, b, and c in the formula. So a in this case is positive 2, b is positive 4, and c is negative 5. Okay, now let's use the formula to find our solutions. The formula tells me that the x values, the solutions, are negative b, so negative 4, plus or minus the square root of b squared minus 4 times a times c. So I'm filling in the values for a, b, and c here. And then on the bottom, 2 times a, which is 2. Now what you do is you simplify it. Now I always really simplify this in pieces, in 3 pieces. So the first number here is negative 4, that's fine. But I want to simplify this square root. Now I first want to figure out what's underneath the square root, so I'm going to take 4 squared minus 4 times 2 times negative 5, and I get 56. So I've got the square root of 56, and then on the bottom I'll simplify 2 times 2 is 4. So start there by simplifying underneath the radical sign and then also your denominator. Now the square root of 56. 56 is not a perfect square, but I can simplify it. 56, just kind of off to the side here, is 4 times 14. So I can simplify this square root because 4 is a perfect square. The square root of 4 is 2, and so if I kind of bring it out in front here, square root of 4 is 2. What I really have is 2 times the square root of 14. Okay, so now my fraction looks like this. Negative 4 plus or minus the square root of 56 simplifies into 2 times the square root of 14, and then we've got over 4. Now if you wanted to leave it like this, that'd be just fine, but we can reduce this fraction. 4 is our denominator here, and 4 goes into 4 once, and I can really reduce 2 over 4 into 1 over 2, 1/2. So the best answer would be x equals, now I'm going to reduce each of these, so I get negative 2 plus or minus the square root of 14 over 2. I reduced each of them by 2, and that's what we have. You could also write it like this. Here's another option. Negative 4 over 4 is negative 1. Then I could say plus or minus in the middle. 2 over 4 is 1/2 times the square root of 14. Either answer is fine with me. What we really have here is a long decimal, an irrational number, and you found some of these on your calculator back a few lessons ago. When you found the two solutions, your calculator would approximate them to maybe 5 or 6 decimal places, but what we really had for solutions in those cases were irrational numbers or square roots. Let me give you another example. So the quadratic equation is x squared plus 13 equals 4x. Again, it's not in standard form, and so I'm going to subtract 4x on each side to begin with. And be careful now, make sure that you're putting it in the correct order. I want x squared first, minus 4x second, plus 13 last, and then equals 0. So now my a value is 1 because I really have 1x squared. B is negative 4. and c is 13. Let's plug a, b, and c into the quadratic formula and see what we get. So the solutions are equal to negative b, that's a negative negative 4, plus or minus the square root of b squared, so negative 4 squared minus 4 times a, which is 1, times c, which is 13. And then you divide that entire thing by 2 times a, or in this case 2 times 1. All right, let's simplify. The negative negative 4 becomes positive 4. These two negatives will make a positive. And you've got the plus or minus sign in the middle up there. And we're going to simplify underneath the square root. Now, here's where students always make a miscalculation. Negative 4 squared is positive 16. Negative 4 times negative 4 is positive 16. So if you're using your calculator to simplify this, you need to make sure you have parentheses around the negative number. What we end up getting is negative 36. And then our denominator is 2 times 1, so that's 2. So I've simplified, kind of in 3 pieces here. The first number, the square root, and then our denominator. Now let's simplify our fraction or reduce it if we can. The square root of negative 36 tells me that my solutions are going to be complex because the square root of negative 36 is an imaginary number. It's actually 6i. So let's simplify that square root into 6i. And then if you look at our fractions here again, 2 is our denominator. I can reduce this. 2 goes into 4 twice, and 2 goes into 6 3 times. So 4 over 2 is 2. Plus or minus is in the middle. 6i over 2 is 3i. So we've got a complex solution here. 2 plus 3i or 2 minus 3i. Those are the two solutions. Now, what happens with this graph? Well, when you get complex solutions, the parabola never crosses the x-axis. These are non-real solutions or imaginary solutions here. So they don't necessarily show up on the graph, but we can find them using the quadratic formula. Okay, so we can actually figure out the number and the type of roots for a quadratic equation using what we call the discriminant. The discriminant is the expression b squared minus 4ac. It's exactly what's underneath the square root sign in the quadratic formula. So if that square root is positive, or if that discriminant is positive, and if it's a perfect square, we know that that square root will simplify and you'll get 2 real rational roots. And the graph for that would look something like this. I'll draw this one upside down just to give you a different example. Some kind of parabola with 2 real rational roots. Rational meaning they'd be easy to find on the graph, like -7 and -2, or -8 and -2.5, or something like that. If the discriminant is positive, if we have a positive square root, but it's not a perfect square, like the square root of 56, we're still going to have 2 real solutions, but these are irrational, meaning the decimal will go on forever and ever and ever. So the parabola will still cross at 2 points, 2 x-intercepts, but these would be like messy decimals, and you could approximate them on your calculator, but if you're using the quadratic formula, you would leave this square root in your answer. If b squared minus 4ac is negative, like in that last example when we had -36, well, that tells you that you're going to have complex or imaginary roots. And we know what that looks like already. I just drew you the graph. The parabola will not cross the x-axis. Doesn't mean that there's no solutions. They just happen to be complex or imaginary. I'll put a little I here so you remember. And then if b squared minus 4ac is 0, you'd be taking the square root of 0 and you get 0. Well, plus or minus 0 doesn't change, and so you've got just 1 real rational root. And your parabola maybe would look like this, where the vertex only touches at 1 point when you get 1 solution. So this is the last example. We want to find the value of the discriminant and describe the number and type of roots for the equation 9x squared minus 12x plus 4 equals 0. So to find the discriminant, I need to take b squared minus 4 times a times c. B is negative 12, A is 9, and C is 4. So here's A, B, and C. Let's plug them into the equation. So B is negative 12, so that's negative 12 squared, minus 4 times A, which is 9, and C is 4. Well, negative 12 squared, that's positive 144. And 4 times 9 times 4 is also 144. So our discriminant is 0. Now, what does that mean about the number and the types of roots or solutions? Well, that means that there's one real rational root. That's really what you want to know or what you want to find out. And then, of course, if you wanted to know what that root was, we could try to find it on the graph, or we could use the quadratic formula. I'd like you to try these on your own and bring them to class with you. So solve number 1 using the quadratic formula. And then number 2, just find the discriminant and then tell me how many solutions and of what type they are.